and seriously, don't be shy. A lot we're talking about is on these boards, so well, let's be real tight and friendly. Yeah. My name is John Sobiek. I'm a biologist on the project since 2008. This is Craig Evans, planning, and chief of planning now. I've done the project since before that time. And at this stage, what we're going to do is we're going to kind of give you an overview of why we are where we are today with the project, and then Craig will talk a little bit about how this project's going to function and operate. This is kind of the big reason why you guys are all here, right? See this thing behind us? This graphic here, there's a bunch of renderings. It kind of shows what Craig already talked about. But this is a graphic of the Maple River aqueduct. Maple River is flowing in west to east over the top of the aqueduct, so it's actually flowing over the top of the diversion channel. The diversion channel is flowing.
All right, my name is Matt Lueker. I'm from the University of Minnesota. I work at the St. Anthony Falls lab there, and we do a lot of this physical modeling. We've been doing it for 50 plus years. And so we were hired by the Corps to perform this model. We're typically in Minneapolis area, but we're out in Umore and Rosemont. Just because of the expanse of this model, we didn't have room for it. Just to quickly discuss some of the construction techniques you're standing on, Jeff will discuss that more over there, but the model is completely made out of wood and concrete. All of the curved sections are poured in concrete, and at standard accuracy of half a foot in the full scale prototype.
Okay, let's go. We're good. We got air conditioning, so everybody likes this. We'll sit here. We'll be here for 8 hours all day long. It'll be lots of fun here. Good morning. My name's Glenn Krogman, and this is Andy McCoy. And we're going to talk to you a little bit about the most important part of the entire project. That's numeric modeling, hydraulic modeling, computer modeling. That's what we do for a living. It's great stuff. It's just spectacular. So there's two things. There's hydrology, which that's flow rate. So that's 29,000 CFS on the Red River at Fargo during the 2009 event. That's flow rate. That's hydrology.
So this model that is behind you, the methods used to construct models have not changed in a long time. We've got lots of model photographs at our laboratory. The laboratory I work at is in the Twin Cities in Minneapolis, and there are a lot of black and white photos from 1940 of models just like this, and the techniques they used are very similar to what we use today. What's changed is the input data. LiDAR and allows us to come in with a lot more information on topography, and then the data collection techniques have just advanced tremendously.
And this last station here is just kind of talk about where do we go from here with this. You know, we built this model, we're testing it. What's the purpose of that, and what are we going to do with it? First of all, this is just we've done some initial testing with this. We've got the broad outline of how the water flows over the aqueduct and down the channels, how those interact with each other. And we found that already there are some things that we can tweak with the design which should hopefully make it a lot better. But this is really a unique project in some ways in that there really are very few aqueducts that are constructed in cold climates. And in this instance, Fargo is pretty cold in wintertime. During the winter you have extremely low flows on the Maple River, and we have to have concerns about whether that will ice up, prevent flows through there. And if it does, what is the result of that?